given, and of course we're being told to find A, B, and C. Now, because of the way this is written, it's actually giving us another set of values we can plug into there. So we're going to be able to get two equations out of this point and this point. Okay, so just like you did, we can write that when x is 1, we get a times 1 squared, so that's just 1a, plus b times 1, so that's just b, plus the c, and because we're using this point here, the y value, or the answer, is 2. And that gives us our first equation. Okay, then if we use this point, we are going to substitute the x in there, x value of 2, so 2 squared is 4, and therefore we have 4a, b times 2, and that's c again, and this time the whole thing comes to 1. So now we have two equations. Okay, now as you rightly did before, the gradient function will be 2ax plus b, and we know that this is 0 when x is 2. In other words, 2 times 2 times a, or 4a, plus b equals 0. Just rearranging that slightly, we can define b as negative 4a. Okay, and that now gives us a third equation that we can use. You could use either of these two, but I'm going to use this one. And what it now means is that you can substitute wherever you see b up here, you can replace it with negative 4a. And what that will give you is it will give you two equations with only a's and c's in them, which you can then solve simultaneously fairly easily. Okay, so let's just do that to sort of complete the job. If we substitute into 1 and replace, we're going to replace that b, so it's going to be a plus, and now instead of b it's going to be negative 4a, whoops, plus c equals 2. Same again with the second equation, so we had 4a plus 2b, but of course instead of b we have got negative 4a, and then what do we have? We had plus c, and this time, because we're substituting into the second equation, that was equal to 1. Let's tidy these up slightly. So this goes to c minus 3a equals 2, and this one gives c, well, this bit here goes to negative 8a, so c minus 4a equals 1. Okay, so now we have, we have two more equations. They both share this c, so we can eliminate by finding the difference. So if we do equation 4, take equation 5, we will get no more c's. Negative 3 minus 4a will just be positive 1a. 2 take away 1 will just be 1. And So now we plug the a back in there, so we would get that therefore b must be worth minus 4 times a, so negative 4. And finally c, use any of the equations, but I guess if we rearrange this, c would equal 2 plus 3a, or 2 plus 3 in our case, and therefore c is 5. Shall we just have a quick check if we write it out properly? So we think we've got an answer, but let's just write it out to check. The theory is that y equals 1x squared minus 4 plus 5, and remember we have these 2 points that's supposed to go in there, so let's just check. If we plug a 1 into here, 1 squared minus 4, that's negative 3, plus 5 does equal 2, so that works with that one. Let's try the second point, and we'll plug in a 2 and hope for a 1. So 2 squared is 4, take away 4 2, so take away 8, that's negative 4 plus 5, guess what, it gives us positive 1, so job done.